Hello everyone, my name is Nick. I'm with VoltForge Labs, and today we're going to be talking about three types of 3D printer filament. We're going to talk about PLA, PETG, and PHA. The first two, anyone with a 3D printer has heard of. The last one, very few people have heard of, let alone used. So we're going to go over the strengths, weaknesses, and practicality of each filament when it's best to use them. I have some prints behind me that I've printed with each of the mentioned filaments. We'll go over that in extensive detail, but I'm really excited for this video and to explore these filaments. So thank you for watching, and I hope you like this video. All right, everyone. So this PowerPoint is going to go over how to pick between PLA, PETG, and PHA for the project, the planet, and the budget. So PLA is the default starter filament. It's the one everyone's going to be familiar with. If you recently got a 3D printer, I can almost guarantee you that a small spool of PLA came with your 3D printer. It's going to have several printer profiles ready to go. It's going to be the easiest to print. It's going to be the lowest cost, and it's going to have thousands of varieties available at your fingertips. Amazon, Creality, Bamboo, they all make PLA filament. It's easy to print and it's rigid, so it's used for things like desktop prototypes, display models, cosplay props, and figurines. PETG is going to be tough and it's going to be durable, so it's going to be an alternative to PLA if you need something stronger for maybe a functional part. It's less heat resistant, UV stable, and more water resistant. And PHA is the Eco Upstart. It's the only compostable or biodegradable 3D printer filament on the market, and it's a new niche. People are still figuring out how to use it, what it's good for, what it's bad for. But right now, its key use would be things that don't need to persist into the future very long. So if you're 3D printing something and it only really needs to exist for 2 months before you throw it away, that would be a good candidate for PHA filament. Now, when you're deciding between the three, there are going to be some factors you want to consider, such as the strength, the stiffness, and how it breaks. So you can see for PLA, PETG, and PHA, we've got a couple of variables on the left-hand side. The first is going to be tensile strength. So that's the maximum stress that a material can withstand before breaking. Below that, we have Young's modulus, which is how stiff something is, or its ability to resist being stretched or compressed. And we have elongation at break, which is the percent increase of length prior to break. So essentially, it's how much can something deform before it breaks. And we have impact strength, which is just the ability of a material to absorb energy and resist failure under a sudden high stress load, which would be an impact. Below that, we have softens at temp, which is just the temperature that something, or the material, the temperature at which the material softens. So you can see for PLA, we have 55 to 60. For PETG, we have 75 to 80. And for PHA, we have 100 to 140. And those are in degrees Celsius. So if you're in America, you can convert that to degrees Fahrenheit. Below that, we have how it fails. And a brief synopsis or a brief summary of this would be that PLA is the stiffest, but it's brittle. PETG is a balance of strength and toughness. And PHA flexes the hardest, but it trades in raw strength for that. Filament print profiles are something that you're going to also need to consider. You're going to need to tune these to get the best prints off of your machine. And things like nozzle temperature, bed temperature, whether you have the cooling fan running, whether you have an enclosure around your printer. These are all things that you're going to need to dial in, and each filament type has different specs around these. So for PLA, we've got a nozzle temp of 190 to 220. For PETG, it's about 230 to 250. And PHA, it's about 200 to 230. When I print PHA, I run it at about 215C, and that seems to be the sweet spot for me. Both PLA and PETG run a hotbed. PLA, it's optional, but one of the weird things is for PHA, you want to have a cold bed. You don't want to have any heat on that. The cooling fan, it varies. Sometimes you can let the slicer determine it for yourself. But for cooling fan, most of the time for PLA and PETG, you're going to have the fan on. For PHA, have the fan off. Cooling too quick on PHA can cause warping, so just printing with the fan off will help alleviate that headache. Enclosures, none of these really need to have enclosures. You can if you want, but it is not required for any of these filaments. Some of the common headaches for each of these are PLA will string if it's too hot. PETG will also string. And PHA, If the bed is warm, it will warp as the print cools, which is why we run a cold bed. For build plate type, PLA can use just about anything, glass, PEI, or painter's tape. PETG, textured PEI, or a glue stick works best. And for PHA, you're going to want to get a BuildTak Pro plate. You can use textured PEI, or you can use printer's tape for it, painter's tape for it. But the issue is it's going to warp and it's not going to stick great, so you're going to want to have a brim on those. The BuildTak Pro plate is the only printing surface I found that I did not need to have a brim on PHA for. So the ease of use and forgiveness for each of these is something that's going to also be extremely critical to consider when you decide which filament you want to use. PLA, hands down, is the easiest. If your first layer works, there's a 99% chance that the rest of your print's going to work. Default slicer presets work out of the box, so you can hit print and walk away essentially as long as your first layer sticks. PETG, it prints reliably once the temps are dialed in, but if you have something out of line, it'll punish you. You'll get stringing, you'll get drooping. It can grip the build plate too aggressively if you're not using the right build plate. And PETG also soaks up moisture, so you're going to need to constantly dry it unless you have a good storage system for it. Now, PHA is the most advanced in terms of the use cases. Again, it requires a BuildTak Pro plate or a brim on textured PEI. The settings are going to be cold bed, fan off, nozzle near 215C, and it'll warp if the bed runs warm, which is why we run a cold bed. And you need to let the print secure on the plate for a few hours after finishing so the layer's fully set. So you can see PLA is the easiest and PHA is the most difficult, but any of these, once you get a solid print profile dialed in, they'll print beautifully. There's none of these that are inherently not good to use. Another thing that you're going to want to consider when choosing between the three is going to be what happens to my print after I'm done with it. And I don't mean after it's done printing, but I mean when you're done utilizing the print and you get rid of it. What's the end of life for it? Where does it go? Just because it's not in your house doesn't mean it's gone. So PLA is sourced from corn and sugarcane. It's bio-based. It claims it's biodegradable, renewable, XYZ. You can put any catchword in there. Full disclosure, it's not. If you were to just take PLA and throw it out, it's going to persist 80 to 400 years in nature. It'll shed microplastics as it slowly fragments, and it never truly biodegrades. The only way to biodegrade PLA is in an industrial setting, which it'll never see because there aren't really places set up to do that. PETG is another petroleum-based one. Because it's a polyethylene, it could be recyclable as number one in theory, but it's not going to be accepted as PET by most recycling plants. So if thrown away, it would persist for 450 to 700 years in the wild. It would fragment into microplastics along the way. And honestly, the most responsible end to it would be incineration, right? So again, not a bio answer. PHA, on the other hand, it's sourced from bacterial fermentation, and it's the only true biodegradable filament out of the three. So it would break down in months, not centuries, and it's fully metabolized by microbes. It leaves no microplastics behind. So within 6 months to a year, it would be fully biodegraded with no microplastics left behind. So that's something you should consider when you're picking your 3D printing filament. How long do I need this print to last, and what do I want to have happen to it when I'm done with it? And with the way the economy is currently, everyone is pocket watching, right? We're all watching our wallets, trying to get the best deals with everything just to make ends meet. PLA and PETG are much cheaper than PHA. For PLA, you're looking at $14 to $30 a kilogram. Basic PLA is going to be on the cheaper end, but specialty variants are going to be pushing the $20 to $30 per kilogram mark. PETG has also dropped a lot, so same thing. Cheaper end, you're going to have the 14, 15 to 20, and then higher is going to be above 20. And because PHA is a niche filament, It's not mass produced yet, and it's not bought in the hundreds or thousands of kilograms. So it's going to run you $30 to $55 a kilogram. Places I've personally bought PHA from would be Polar Filaments, Ecogenesis Biopolymers, and ColorFab has an all PHA. But all of them were between that $30 to $55 kilogram price range. So there are some honest trade-offs with these filaments. PLA is going to be the easiest to print. It's going to be cheap and universal, sharp detail, low warp, and quote-unquote a bio-based feedstock. The cons are it's brittle under stress, it softens above 55 degrees C, so it's not really viable for outdoor uses, and it's not home compostable despite what they will tell you, and it has poor UV and outdoor life. PETG, it's tough, it's impact resistant, it's water and chemical resistant, it can handle heat up to 75 degrees Celsius, so much better for outdoor or functional use. And food contact grade exists, but I would never use anything I 3D print for food purposes, full disclosure. The cons, right? PETG, it strings without good tuning, it's hygroscopic, so you need to dry it. It absorbs moisture. So if you leave PETG out for like a week or 2 weeks, you're going to need to dry it before you use it again. PETG is not recyclable, and it takes over 600 years to degrade. And then PHA, it's truly home compostable, no microplastics, it's UV stable, and some blends survive to 120 degrees Celsius. The cons, it's quite expensive. It's got a quirky print setup. It's definitely the most difficult out of the three to print. There are limited slicer profiles available for this, so you're probably going to have to make your own, unlike PLA and PETG, which just have hundreds of profiles available. And PHA has a post-print curing time where the layers need to set and crystallize before you can use the print. So I've made this table to kind of help you if you're not sure what the best filament for each thing is. If you're printing minifigures, models, or prototypes, you can use PLA. For mechanical brackets, tool holders, outdoor parts, planters, garden tools, bottles, kitchen organizers, you're probably going to want to use something like PETG. For disposable or compostable items, the only option is PHA. For test prints, trinkets, and short life prototypes, these are things that I've designed this in CAD or Onshape or some other software, and I just need to see if it works before I print it with PETG, but I'm going to throw it away. That's something that PHA would be good for, because you're going to print it, you're going to measure it, see if it fits, and then it's immediately going to go in the garbage. So that's a prime candidate for PHA. Your first print on a new machine, PLA. I would argue to the end of the world that your first print on a 3D printer should be with PLA. And if it's going to be a sun-exposed part or in a hot car where you need more temperature resistance, you can do PETG or PHA depending on how long that item needs to persist into the future. So, in summary, PLA, it's the default. If you need something that's reliable, it's cheap, and it just works, buy PLA. PETG is going to be your everyday workhorse. If you need something that's strong, impact resistant, and it needs to serve a functional purpose and not just look pretty, go PETG. And if you're an eco warrior, or you care what happens to your 3D prints after you're done with them, after you throw them away, and you have the budget to do so, I would go the PHA route, right? It's a bit pricier, it's kind of fiddly, so if you like puzzles, figuring out what print profile works the best, and you want to know that when I'm done with this print, I won't be leaving a mark on the planet, this will biodegrade and go back to the earth, it's the option for you. So that's the PowerPoint on which 3D printer filament you should use. I hope you liked it, and I'm going to show you some things that I printed with PHA, PLA, PETG, and we can see the quality of each filament, and then you can make the decision for yourself. So thank you.